हाँ जी बच्चों, टुडे वी आर गोइंग टू डिस्कस द ट्रांसपोर्टेशन प्रॉब्लम. What is there in a transportation problem? As the word indicate, the movement from one place to another one. Especially when we are talking about the linear programming. In last lecture we were talking about the linear programming problem, LPP. When the number of constraints are getting more and the variables are getting increased, in that case it is difficult to solve the problem with the linear programming problem. You can solve the problem with the linear programming problem also, but it is better in that case you go with the transportation problem. And moreover, when there is a movement from one place to another one, for that we make use of the transportation problem. And one thing is more, we will always keep in mind that this transportation, as the word indicate, the placing from one place to another one. So let us have, for that one, in this lecture we are going to calculate only the initial basic feasible solution. This is also known as IBFS. This is also known as IBFS. Let us have one problem. This is a 3 by 4 matrix. There is a 3 by 4 matrix. It could be any matrix. This is 3 by 4 matrix. This is given to you. This is the balanced one. I am taking one problem. What is there? We are going to calculate only the initial basic feasible solution. This is a factory. This is a factory. F1, F2, F3. There are 4 warehouse. There are 4 warehouse. What is warehouse? W1, W2, W3 and W4. There are 4 warehouse, W1, W, and this is the cost which is associated with this one. Let us assume we are taking a cost. This is 9, 3, 5, 1, 7, 3, 4, 6, 4, 8, 7, 2. And moreover, this is the capacity. This is the capacity of the factory. This is 7. What is the factory of F2? This is 9. This is 18. The F3 is 18. And what is this? This is the requirement. This is the requirement of warehouse. This is 5, 8, 7, 40. Look at here. Look at here, this is the problem which is given. If you count it here, 7 plus 9, 16 plus 18, 34, this is 21 plus 13, again this is 34. If these are equal, capacity and requirement is equal. This is the first constraint which should be met. If it is not met, then we have to rearrange the problem. So this is basically for that one. There are 5 methods. What are the 5 methods? Let me go through that one. I am going to discuss one by one. One is called the northwest corner rule. Northwest corner rule. The second one is row minima method or rule. Third one is column minima method. Fourth one is least cost method or rule. And this is called Vogel. Vogel was the scientist. That is called the Vogel's approximation method. Today we are going to calculate only the initial basic feasible solution. Whether this solution is optimal one or not, for that we need to perform the optimality test. We will discuss that thing in a separate class. Now, what is the northwest corner rule? Look at the first one, northwest. And this is also known as northwest corner rule. Look at the northwest corner rule. We will discuss one by one. Here, I am taking the same matrix, 3 by 4. This is 3 by 4 matrix. This is 9, 3, 5, 1, 7, 3, 4, 6, 4, 8, 7, 2. This is 7, 9, 8. And here one thing you please note down. All these are the cost matrix, cost component. These are the cost components, and these are in units. These are in units. So there is no relation between this and this. This factory you are going to supply from F1 to W1, it costs rupees 9, and you can supply 7 units. So it could be 7 container or anything else which you can feel. Now what is the northwest corner rule? If you look at here, this is the northwest corner rule. This is north, south, east, west. So this one is called northwest. This is called northwest. And maximum allocation which can be made 5 and 7 if you look at here. So 5, if I take the difference of this 5 on this side, this we are left 7 minus 5 is 2. So here you are going to shift 5. Now this row or this column has been exhausted. Go to this one now. Again northwest, this is 2, this is 8. The minimum value is 2, this is 0, this is 6. This has been exhausted. You can't move further till the whole of the row and column has not been exhausted. Initially we will go with the row. Now this is the northwest. Maximum allocation 6, 0, this is 3. Clear? This is 0 here. What is here? 3 and 7, this is 3, this is 0. Demand and supply. Whichever is less, you are going to delete that one. That is going to be exhausted. This is 0. This is 4. This is 0. This is 14. At the end, what will happen? Now this is, at the end, your demand and supply, it will be matched. This is 3. Now after that, what you are going to do? You are going to calculate the TC. What is this TC? This is called total cost. Whether this is optimal or not, this is the second issue. We will discuss that thing in a separate class. Today we are going to discuss only the initial basic feasible solution. 9 into 5 plus 3 into 2 plus 3 into 6 plus 4 into 3 plus 7 into 4 plus 2 into 14. This is 45. This is 6, this is 18, 12, 28, and here it is, this is plus. This is plus 28. This is 50, this is what you are getting, this is 51 plus 30 plus 56. This is the cost, 7, this is 137. It costs rupees 137 when you are using the northwest corner rule. Means the movement from factory 1, F1, F2, F3 to the warehouse W1, W2, W3 with the capacity of this 7, 9, 18 and a requirement of 5, 8, 7, 40. So we go to the second one, row minima. I am taking the same problem. Now this is the row minima. I am taking the same. Look at here, row minima. Row minima, again I am using 9, 3, 5, 1, 7, 3, 4, 6, 4, 8, 7, 2. 4, 8, 7, 2. Now, here if you look at here, this is 7, 9, 18. This is 5, 8, 7, 14. Look at here, row minima. Row minima is out of this first row. Look, out of this row minima means the first row, look at the first row, the least cost is 1. The maximum allocation 7 or 14. This is 7, this is 0. First row has been exhausted, this is 7 here. Go to the second row, the least cost is 3. The maximum allocation which can be made 8. This is 0, this is 1. This is exhausted. Go to this next higher, 7, 4, 6. This 4, this is 1, this is 6, this is 0. Second row has been exhausted. Go to the third row. The minimum value is 2, maximum allocation can be made 7 or 18, 7. This is 11. This has been exhausted. 4, this is 5, 0, this is 6. So this is 6, 0, 0. Again calculate TC. Once we calculate total cost, means this total cost. TC is nothing, basically the total cost. This is the second method. Look at here, 1 into 7 plus 3 into 8 plus 4 into 1 plus 4 into 5 plus 7 into 6. Look at here. This is the cost associated, you are moving 6 units. 2 into 7. Look at here. This is 7 plus 24 plus 4 plus 20 plus 42 plus 14. This is nothing basically, if you count it, this is 31 plus 24 plus 56. 1, 4, 2, 6, 5. This is 1, 1, 1. If you are having a choice, if you are using two methods so far, this is the northwest, this is the row minimum method. Row minimum method. You are satisfying both the things, capacity and requirement, and if you are have a choice, you will prefer this row minima. Why not? Because here you are spending 137, here you are spending 111. Now I am going with the third method, that is the column minima method. This is the third method for finding out the initial basic solution. Now this is the one. Again 3 by 4 matrix. Again 3 by 4 matrix. Look at the matrix 3 by 4. This is 9, 3, 5, 1, 7, 3, 4, 6, 4, 8, 7, 2. Now this is 7, this is 9, this is 18. This is 5, 8, 7, 14. We are taking the same problem. Now column, look at the first column, the least cost is 4. Maximum allocation which can be made 5 and 18, 5, this is 13. The first column is exhausted. Go to the second column. You have a choice 3, 3. Randomization, I choose the first one, 7. This is 0, this is 1. This is exhausted. Here it is 1, this is 0, this is 8. The second column has been exhausted. Go to the, this is the 4. Third column, least cost is 4 and 7, 4. This is 7, this is 0, this is 1. This has been exhausted. Go to the fourth column, the least cost is 2, this is 13, this is 13, this is 0. Sorry, here it is 1. This is 1, this is 0, this is 0. Again calculate total cost for column minimum. Now TC, calculate the TC. Look at here. 3 into 7 plus 3 into 1 plus 4 into 7 plus 6 into 1 plus 4 into 5 plus 2 into 13. Once I calculate this one, this is 21 plus 3 plus 28 plus 6 plus 20 plus 26. This is 24, this is 34, this is 46, this is 46. This is 104. Now, if I having a choice between this northwest row minima and column minima, the column minima will give only the 104. So this is the third part. So we go with that. I think this is all about of these three parts which we have discussed. Rest we will discuss in a subsequent section. Second session which we are going to discuss this one, least cost and approximate method. Thank you very much so far.